Hello everyone and welcome to my YouTube channel The Math Bender by Adnan Zabi. I've already discussed trigonometry in its entirety of mathematics IGCSE, GCSE and O levels, but this specifically is about AS level mathematics and add maths precisely. And this is the first section of trigonometry where I'll discuss sine curve, the sketching and its dynamics of a sine curve. So let's say if we start off with the basic parent function. So parent function is all what when everything started off from. So when I say trigonometry, I talk about sine, cosine, tangent, and many other functions that we can discuss later on. But this is basic sine function, and if I have to roughly get an idea how it looks like, so let's write down some values here in 0 degrees, 90, 180, 270 and 360. And if I find out these values, I will see that sine of 0 is 0. So I'll write down these values here as well. So 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 becomes -1, and you can try plugging in these values and this becomes 0. So this is how it is a curve, and you can see that at 0, when x was 0, the y value was 0 as well. So this is the point where it all started off from, and when sine was 90 it became 1, attained a 1, and then at 180 degree became 0 again, and hence -1 and 0. This is a basic sine curve in degrees. So when x is in degrees and y is equals to sine x, where this is 90 degree, this is 180 where the curve became 0, this is 270 where the curve became -1, and this is 1. And this here is 360 again. Now, this curve is not limited to this section, and we'll discuss more on that. But this is just a basic curve. This is how you see where it starts from 0 to 360. The domain of this curve is 0 is less than x is less than equals to 360 degrees. The same goes if I convert my calculator to radian mode and I take these values in 0, 90 is pi over 2, 180 is pi, this is 3 pi over 2, and this is 2 pi. And if I take these values in pi radian, so sine 0 is again 0. If I plug in sine pi over 2, makes it 1. And you can keep on plugging these values, you get the same values that I'm writing down here, and 0. So the same curve, but just that the unit of angle measurement is in radian here. So instead of 90 degree here, you write down pi over 2. This will become pi. This is 3 pi over 2 where the curve reaches -1, and this is 2 pi. 1 and -1. This is by default the basic sine parent function. Everything is just an extension of it. So the characteristic is this curve is a many to one function, as you can see by default. You can convert it into one to one by breaking it down to different domains, but this is a many to one function. The by default range of this function is -1 is less than equals to sine of x is less than equals to 1. So it only fluctuates between -1 and 1. The domain or the period of this function is 360 degrees by default. I'll discuss what period is in my next page. So let's see if we draw a full scale sine curve here. So now if you see this, I am drawing multiple waves, and those waves are not just limited to positive x, can also be negative. Now in this whole thing, this part is the sine function one wave, and after that wave is completed, the function repeats in itself. So we know that this is 90, we already talked about it. This is 180, this here is 270, here is 360, as you could see, just adding 90s. Now if I add 90 further, this will become 450. 9 times 5 is 45, this is 540, 630, and this becomes 720. The same behavior is back, negative 90, this here is negative 180, negative 270, negative 360, and so on. So after one wave, it will keep on repeating. So you can draw, and if you want to write this down as a domain of this function, the domain of this current function that I've drawn is negative 720 is less than equals to x is less than equals to 720, because I can see this curve from negative 720 to 720. The curve keeps on going. It by default, if you see, the wave has infinite domain because it will keep on moving. So the questionnaire will ask you in a restricted domain, and we'll see some of the questions now. The range of this function lies between, again, negative 1 to 1. So negative 1 is less than equals to y, or sine x is less than equals to 1. Now this stretch here, if you see, this stretch here is of 1 unit. The same stretch is here, is that it says as well 1 unit. So the vertical stretch is called the amplitude. And so if, let's say, this is y equals to a sine b x, so this a part represents the vertical stretch, and in this case it is the amplitude, the height of the wave. And height is always measured from the center. Now period is the number of degrees where one wave is completed. So in this situation, as you could see, one wave started off from this 0 and it ended at 360. After that, there is a repetition behavior. You can take it from anywhere. So this is the period. By default, a sine wave has a period of 360 degree. So degrees or radian angles taken for one wave to complete. Now this is the height of the wave. This here is called the maximum value. The wave does not exceed that point, which is 1, and this here is minimum. So maximum and minimum are the heights, opposite ends. So let's try to construct some different domains sine wave and see them, how, if we can draw them. So this is a basic parent function. First of all, I'll draw that basic parent function so we can have a reference point. This is a basic parent function, and I can see that this here is 0. By the way, all of the angles that I'm writing down are in degrees. You can use the same for radian as well. So this is 90 degrees, this here is 180, this here is 270, and this here last point is 360. The value is 1 and -1. This curve is the basic parent function between the domain 0 is less than equals to x is less than equals to 360 degrees. Now, let's say if I have to draw for 0 is less than equals to x is less than equals to the same function for 270 degrees. So the curve will be like this, and that's it. The question is asking or restricting me within this domain for 0, 90, 180, and this is 270. It does not mean that the curve is not ahead of it. It is, but the question wants you to restrict your graph within those domain. So let's say if we still have, we can try drawing it from negative 270 degrees. It's less than equals to 0 is less than equals to 90 degree. So first of all, I can see that this here is 180 degree, but I need to restrict myself to 90 degree, and I can see that this here is my point until 90 degree. So what I could do is I'll erase it, and that's it. This is my 90 degree where the graph touched 1, and going backward makes it negative 90, 180, and then 270. So this here is negative 90, this is negative 180, this here is negative 270 degrees. The graph may look like this for this domain, although it just occurred to me that it looks familiar to any other graph, but we'll discuss about that later on. So let's say if I want you guys to draw the same y is equals to sine of x for the domain negative 90 is less than equals to x is less than equals to 90 degrees. You may pause the video and try drawing it yourself. Until then, I'll draw it here. So this is 90 degree. The graph is going to be like this. This is 1, this is -1. The domain is negative 90 to 90, and the range of this function is going to be -1 is less than equals to y is less than equals 1. Now, if you look at this function, now it is one-to-one function. The previous one, or the original one, we talked about that it was not one-to-one function. So you may draw multiple other domains for the sine function. Let's look at more questions here and the transition of it. So this is our basic sine function. This is 0, this is 90, this is 180 degrees, this here is 270, and this here is 360. Note that I only am taking 0 to 360. That does not mean that you cannot draw 2 waves, 3 waves. It's up to you. But this is the basic function. So the purpose is to understand what are these operations acting upon. So here, so the function by default has a domain of 0 is less than equals to, or I could write that down, that it has a period of 360 degrees. The range is -1 is less than equals to y is less than equals to 1. You may also write that down like this. Both ways it's correct. Domain, we already know that 0 to 360, and the amplitude is 1. this function. So amplitude is 1, this number that is multiplying 1 times sine x, and you can see that this height is 1. Now if I say sine x plus 1, so the function translates 1 unit up. So the value which was -1 translates 1 unit upward to give you 0, and the value which was reaching at +1 translates 1 unit upward to give you 2, and the value which was starting off, the function that was starting off with 0, starts off with 1. So in order to have a good idea or understanding, just draw a rough line here, because now this is the line, this is the x-axis. We assume that x-axis shifted upward, so just taking it this way and draw it like this, just for the drawing purpose, by the way. That does not mean the x-axis is over there. Now this height here, after, so this point here, so this value after going 1 unit upward reaches a point 2, start point is 1, and this is basic 0. Now an important thing to know here is, you know that this point here was 90 degrees where the graph reached 1, or its maximum height. So you go downward and write 90 degrees here rather than writing over there. So I'm erasing it over there. So this is 90, but take your references from here. So this point here, this here is 180, this here is 270, and this here go down and makes it 360. The period remains the same, the domain is there, but the range of this function is now 0 is less than equals to y, or sine x plus 1 is less than equals to 2. Now 2 times sine x. Now this here is a multiple, and according to the functions, 2 times f of x means that it is vertical stretch with a scale factor of 2. So every y coordinate is multiplied with 2 to stretch the curve both ways. So as a result, where the original amplitude of this parent function was 1, now becomes increases to 2. So let's say this is our original wave, something like this, where this value is 1 and this value is -1. Now amplifies this value like this. So this value now here is going to be -2, and this value here is 2 because it's multiplying. It stretches. I'm removing the original function. So this is how it is. So whatever the function that you draw, you just have to label it correctly. Doesn't affect any on the domain or the x-axis, so it is as same as 90, 180, 270, and this here is 360. Now the amplitude this way is going to be 2, the height of the wave from the center, and period remains the same as 360 degrees, but the range is from -2 is less than equals to y is less than equals to 2. Now moving on to another one. So f of x minus 2 translates it 2 units down. And as you can see, the original function has its peak at 1 and negative 1. So by moving it 2 units downward, that highest point which was at 1 is now going to move to negative 1. So I'll shift the axis here, and let's draw another reference line here. And now you can see that the curve will look like this. Entirely went from here like this to 2 units down. So this is -2, and the height, since it is 1 unit upward, is -1, and this will be -3. This value here, since this here is 90 degrees, but we don't write it here, we'll write it here, 90. So this is 180 spot, just above that, 180. This is 270, and the last one, 360 degrees. The amplitude is still same as 1, because the height of the curve from the center line, this is the center line, is 1. The range of this function is -3 is less than equals to y is less than equals to -1. Now let's look at some other questions as well. F of 2x. This is a bit complicated and need more focus. So technically, when f of 2x means, if I write in sine 2x, this means that the graph stretches horizontally with scale factor of 1 over 2, which means initially, by when the parent function was like this, so this was 90, 180, 270, and 360, and so on. So the value which was at 90 will now be at times with 1 over 2 makes it 45, 180 will be at 90, and so on. In easy words, you can look at this with another perspective. This means that within 360 degrees, or 2 pi radian if it is in radian, there are two waves that are being covered. So I just draw two waves. And here, the last point here is 360 degrees. The first was 0. Now, in order to find out what these values represent, so the best way of looking at it is, let's see how many divisions have I divided it into 360. So 1, 2, 3, 4, 5, 6, 7, 8. So let's divide 360 divided by 8 gives you 45 degrees. So you can write straight away, this is 45, and add 45 to it, 90, then 135, then this point here is 180, then plus 45 to it makes it 225. Yep. And then plus 45 to it again gives you 270. This here is plus 45 again, 315 and 360. Now, it means that in 360 degrees there are two waves being covered. But the period of this wave is not going to be 360 anymore, because the definition of a period is the amount of degrees or radian, the amount of angle where one wave is completed. Now if you look at it, the one wave was completed in 180 degree. So we write period is equals to 180 degrees. Another way, you know that by default sine wave has a period of 360. So 360 divided by whatever number that is written here, you write it like this. This gives you 360 over 2, which gives you 180 degrees as the period. The range of the wave is as same as -1 to 1. Now let's look at another one, f of 3x. So which means that within that 360 degrees, there are three waves that are being covered. So let's draw three waves. One, two, and three. So these are the three waves. So the last point here is 360 degrees. And the center point here is 180. But even if you don't get an idea, so let's break it again. So 1, 2, these are the crucial points we already have been plotting. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 360 divided by 12. So 360 divided by 12 is 30 degrees. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and so on. The period of this wave is same as 120 degrees, because one wave was completed 120 degrees. If you were to find out without drawing it or without sketching it, you can straight away write 360. By default, you know sine wave has a period, and divide it by this number. 120 degrees. The range is -1 is less than equals to y is less than equals to 1. So note that the domain is what I myself have chosen to be 0 to less than equals to x is less than equals to 360 degrees, but the domain of this function can be any. So the question itself dictates you between what domain values you will have to sketch the same curve. So it could be any. So f of half of x means sine 1 over 2 of x. So which means that within that 360 degree, there will be only half wave that is being completed. So let's draw that out. So this is the half wave. That's it. And if I want to draw the full wave, let's say, so let's first label it. So this is 360 half wave. Half part is 180. This here is 0. And if let's say if someone asks me to complete the wave will take another 360 degree to complete, and hence 720, and this is halfway. So the period of this wave is 360 divided by 1 over 2, which makes it 360 times with 2, which is equals to 720. And you can see that one complete wave is completed at 720 degrees. The domain of this graph is 0 to 720 because the graph, as you could see, is between 0 and 720. The range of this function is again 1 and -1. So f of 3 over 2 or 1.5, I can say that this is sine 1.5x of 3 over 2, which means within that 360 degree there's 1.5 wave complete. So this is one wave and this is half, another half, and this point here, the last is 360. So now if it is getting confusing, so let's break it. So this is 0, 1, 2, 3, 4, 5 and 6. So 360 divided by 6 gives you 60. So 60, 120, 180, 240, 300. The period is 360 divided by 1.5 or 360 times with 2 over 3 gives you 240 degrees. So which means at 240 one wave was completing, as you can see it. This is one wave which is completing 240 degrees. The range of this function is again from -1 to 1. So let's look at some more operations on it. We've already discussed that negative of a function, negative of any function, is a reflection in the line y equals to 0. We call it x-axis as well. So by default, if the function is like this is sine wave. So the function is going to be a reflection in this line and it's going to look like this. This is negative sine of x. The range and domain is as same, 1 and -1. The function exists. We already are aware of the x value, so I just don't need to write down all the values and label it again and again. So absolute value converts all the negative function into positive, and as you could see that this is by default our function, and this here is the negative of it, which means the function has a y negative. So this reflects and may look like this. This part does not change, but this part reflects and looks like this because it is a modulus, converts all the negative values to positive. Since they both had the same amplitude, so this is 1 and this is 180 degrees. The labeling is as same. This is 360, 270, 90, 0. So modulus of a function only converts and reflects negative of y to positive, and reflection is on the line of y equals to 0 or the x-axis. Sine square of x. So as you know that square function is always converting negative to positive. So in this case, although, so this value here is 1 and -1. When you apply on this part, when you apply square over it, so it will become, it will react, in this case it reacts as same as the modulus function because this value was -1. So when you square it, when you square y, -1 square makes it +1. But just in case, let's take another example here. Let's say I'm drawing 2 sine x. So 2 sine x may look like this. This value here is 2, this value here is -2. And when I say 2 sine x square, if I square it, so if I square this, this will become 4 sine square x. And as a result, the value which was 2 is now reflected as 4. So this height is going to be not 2 anymore, it's going to be 4. So this is 360 and you can label the same. Now one last thing on the agenda is f of negative x. So remember that f of negative x, this thing represents reflection on x equals to 0 or y-axis. So let's draw sine function here. So this is our basic sine function. And if I draw sine function with a different light ink, this is my sine function. And if I reflect it on the mirror line, which is this is the mirror line. Now y-axis, the graph will look like this. And if I continue that graph further, it will look like this. And if you look at this shape, the black one, is a continuation of that. You can see that this shape is exactly as negative sine of x. If I extend the same graph backward, it will look like this, which is again a reflection in the y-axis. So hence, we can conclude an identity here that sine of negative x is as same as negative sine of x. Because when we sketch negative sine of negative x and we figured out that it's a reflection on the y-axis and we continued with the graph further, we felt that it is as same as negative sine of x. It's a reflection on the x-axis. So this identity is graphically, this how it is driven. We already have discussed it in our previous section when we're talking about trigonometric functions mathematically. So this is all you need to know about sine function. I'll come up with cosine function in my next video along with some past paper related questions, because I will not be discussing more operations on cosine function because it's as same as the same all of these, but it's just that you need to understand how these operations work on. All you have to do is a different shape will be given, operations will be pretty much the same. But I will discuss more on the past paper questions in my next video. Until then, take care. Bye.